Multiplication rule of probability. In this module, you will learn about the multiplication rule of probability. Consider an experiment of rolling 2 dice. The sample space of the experiment consists of 36 outcomes. Now, consider an event A of getting at least 1 3 on a dice. There are total 11 such outcomes favorable to event A. Thus, the probability of event A is 11 upon 36. If we represent the situation using Venn diagram, then the total possible outcomes of the experiment represent the universal set U, and the outcomes favorable to event A form a set A, which is a subset of U. Now, consider an event B of getting at least 1 2 on a dice. Again, there are total 11 outcomes favorable to event B. Thus, the probability of event B is 11 upon 36. If we represent the event B in the Venn diagram, it is represented by the set B. Now, you can see that some region is common to the set A as well as set B. This region consists of 2 outcomes. Next, consider an event of getting 2 when 3 has already occurred on 1 dice. If we represent this event in the Venn diagram, you can observe that it is a subset of set A and is represented by the region A intersection B. Thus, set A becomes a universal set for such an event, and the probability of the event B when A has already occurred is number of elements belonging to the set A intersection B upon number of elements belonging to the set A. Now, dividing the numerator and denominator by number of elements in set U, you get the numerator as probability of A intersection B and the denominator as probability of A. Thus, probability of B when A has already occurred is equal to the probability of A intersection B upon probability of A. Next, consider an event of getting 3 when 2 has already occurred on 1 dice, or you can say an event of getting A when B has already occurred. If we represent this event in the Venn diagram, you can observe that it is a subset of set B and is represented by the region B intersection A. Thus, the set B becomes a universal set for such an event, and the probability of the event A when B has already occurred is the number of elements belonging to the set B intersection A upon number of elements belonging to the set B. Now, dividing the numerator and denominator by the number of elements in set U, you get the numerator as probability of B intersection A and the denominator as probability of B. Thus, probability of A when B has already occurred is equal to the probability of B intersection A upon probability of B. Since A intersection B and B intersection A represent the same set, probability of B intersection A is same as probability of A intersection B. Now, the two expressions for probabilities help us to conclude that probability of A intersection B is equal to probability of A when B has already occurred into probability of B, as well as it is equal to probability of B when A has already occurred into probability of A. This result is known as multiplication rule of probability. In this module, you have learnt that multiplication rule of probability states that probability of A intersection B is equal to probability of B when A has already occurred into probability of A, which is further equal to probability of A when B has already occurred into probability of B, provided probability of A is not equal to 0 and probability of B is not equal to 0.